that's covered in this. I'm going to illustrate on Sketchpad again. If you want, you can try to follow along. I'm going to be doing some things quickly that like we haven't specifically talked about to create rectangles on this. So you can just kind of follow along and hear me out. I just want you to see it represented visually as your kind of a proof of the relationship. All right, so the second part has to do with the intersection of chords once again, but we're not talking about angles and arc measures this time. We're talking about their lengths. Okay, so if you took two chords that intersect one another in a circle, the relationship that exists between those chords is this, that the rectangle contained by the segments of one chord is equal to the rectangle contained by the segments of the other. Now, the way that, again, that's the historical wording of it. What that basically means is a rectangle is base times height, or length times width. So what it's saying is a rectangle that's formed by a length of xv and a height of vz is going to have the same area or product as a triangle formed by yv and vw. Okay, so let's kind of take a look and see how this is represented. Okay, so if I'm going to create my triangle right here on this point. So my triangle is going to have this length for one, so I'm just going to construct a circle by the center and radius of that, place a point on that, and that is going to be one side. This is my side xv. And now I'm also going to have a side vz. So the way that I can demonstrate that is if I select my other point, choose that distance vz, I'll construct a circle with that measure. And so out here on this, any distance from here to this circle that's now highlighted is my length vz. So a rectangle has what relationship? Its sides are perpendicular. So if I choose this known side and the vertex or endpoint of it, construct a perpendicular. So I know that my third point of my rectangle is going to fit right here. And so all I need to do is one more side is going to be the intersection of these. So if I go ahead and do a perpendicular through this line that's already highlighted, and then through this line that's now highlighted back to the original point, do the same thing, I now have my rectangle. Okay? So what I'm going to do is, here's my rectangle. I'll measure, I'll highlight its interior, Control P, and then I'll measure this area. Okay, so this is the area of VZ times V, XV times VZ. Okay, so what it's saying is that's the same as the area of WV times VY. So let's repeat this with another group. Okay, so the first thing I'm going to do is select my point. I'm going to choose my first side length, VW. So I'll construct that length. Create a side. So here's my length VW. Then from this point, I'll create a length that's a distance of VY away. So construct that circle. And so if I select this point, construct a perpendicular to my original line, I can find the intersection. Here would be my third point of the rectangle, and then just finish this off, perpendicular through here, perpendicular through this final point. And so here is my final rectangle. So if that relationship is right, this purple area should be the exact same as this blue area. So if I measure it, I find that it is. And again, no matter where I move these points, so these figures change dynamically with it. It doesn't matter where I move these, the product of their segments that are cut off are always going to be equal. All right. So here's the relationship, just in terms of an algebraic relationship, is that YV times VW, the product of the segments cut off on this chord, is equal to the product of the segments cut off on the other chord, XV times VZ. And so that's the relationship that you need to be aware of. So let's take a look at some examples. In this first instance, If you have two chords that intersect, then the segments cut off by that intersection have products that are equal. So AE, if that's a length of 6, and DE, this length here is 10, EC is 15, and we want to find BE, so I'll call that X. You can set up an equation and basically say that the product of each segment cut off, so 10 times X, there's the product of the segments cut off for one chord. They're going to equal the product of the segments cut off on the other chord, so 15 times 6. So those are going to be equal products, which means you can now just divide both by 10 to isolate and solve for your X value. And the easiest thing, instead of trying to work with 15 and then times 6, you could just look to cancel common factors, leave it all as factors here. So a common factor of 5 goes into 15 3 times, into 10 twice. Now 2 goes into 6 3 times. So you get your value for X to be 3 times 3, or 9. All right, if we look at this second example, we have DE is 9, BE is 12, EC is 27, and AE, I'll call this Y. So if that's the piece that we're looking for here, we can take the product 27 times Y, has to equal the product 9 times 12. If we divide by 27, again, rather than trying to multiply through, just cancel. 9 goes into 27 3 times, 3 goes into 12 4 times, so you get your answer, Y is equal to 4. All right, if we move to problem 3, we can use the same diagram here. BE is 25, AE is 40, ED is 8, and EC is our unknown. I'll call it Z. So here our product are the product of 40 and Z. There's the segments of one chord have to equal the product of the segments of the other chord. 25 times 8, and just divide by 40. In doing that, 8 goes into 40 5 times, 5 goes into 25 5 times, so you get your Z value to be 5. Again, winds up being easy calculations if you just cancel your factors in that way. All right, so if we look at this final example, if CE is 18 and AE is 8 and BE and ED are equal to each other. So here I'm just going to call these each X. In looking at this, what you wind up getting is X times X is equal to 18 times 8. And if you multiply those through, you get X squared is equal to 8 times 10 is 80. 8 times 8 is 64. 80 plus 64 is 144. Extract the square root. So X is going to equal plus or minus 12. Can you have a length of negative 12? No. So it's just going to be the positive of that. Each of these lengths will be a 12.